Hello, we're Group Benjamin Fish, and we built a bell siphon flood and drain aquaponics system to donate to a third grade classroom. In this presentation, we will describe the process behind building our aquaponics system. We chose a bell siphon flood and drain system because it was low cost and easy to build. Moreover, the system requires low maintenance as it automatically cycles water without needing timers. Finally, the flood and drain cycle helps plant roots receive both nutrients and oxygen, which improves plant growth. We also chose to build a bell siphon system because we felt that it best met the engineering criteria. First, the system is small, so it fits perfectly in the corner of any classroom without disturbing students. The system is cost-effective, amounting to approximately $110, which is a reasonable cost within most third-grade classroom budgets. Given the flood and drain nature of the system, it requires low maintenance, making it safe and suitable for third-grade students. Finally, the system is easy to understand, which would enable third-grade students to learn about aquaponics and take curiosity in the subject.
Our system creates a repeating flood and drain cycle. When the pump sends water up from the fish tank, the grow beds fill and floods. Once the water in the grow bed reaches the top of the siphon activates and drains the water back into the fish tank. Our aquaponics system is meant to create an ecosystem that replicates the nitrogen cycle. We utilize three main types of organisms to achieve this. First, goldfish, which produce ammonia in the form of waste. Second, beneficial bacteria, which convert ammonia from the fish into usable nutrients for the plants in the grow beds. Specifically, bacteria performs nitrification, converting ammonia into nitrite, and then into nitrate. Third, the plants, which absorb the nitrates. To build our aquaponics system, we use several main components. First, the fish tank, which holds the fish and water. Second, the grow bed, which holds the plants, and our hydroton. Hydroton is a growing media which supports plants, provides space for beneficial bacteria to live. Third, we attach 1/2-inch PVC pipes to the water pump, which moves water from the fish tank up to the grow bed. Fourth, a bell siphon, which automatically drains the grow bed when the water reaches a certain height.
Building the system involves several steps. First, we constructed a table out of plywood and 2x4 planks. Then we attached the grow bed to our table, and then we drilled a hole through the table and the grow beds to build our bell siphon. Then we placed the fish tank under our table and connected the pump and PVC tubing. Then we cleaned our hydroton, which took several days of rinsing, and added it to our grow bed. Then we added water to our system and tested it for pH for 2 days before adding plants and fish to our system. While building our system, we made only one change to our original building design, which was to change the angle of our PVC pipe that's attached to our pump. We changed it to better optimize the flow of water into our grow bed. Maintaining the water quality was very important for the health of the fish and the plants. To ensure the health of the fish, we mixed tap water from a hose and water from our fish's original tank that we got them from. We monitored several factors, including the water's pH, ammonia, and nitrate levels. After we initially added water to our system, we added a biofilter containing bacteria that work to break down waste and allow for faster aquarium cycling.
Our favorite part of building this system was when the bell siphon worked properly for the first time. Seeing water drain from our grow bed at the same rate that water was pumped in was gratifying because we knew that our design was successful. A close second of ours was cleaning our hydroton. We had to drain our system multiple times because the hydroton was much dirtier than we had expected, but hauling it back and forth to the sink was very memorable. Even better was clogging the sink and having to help Miss Lee unclog it at the end of class. Our biggest challenge while building our system were assembling our table and adjusting the bell siphon. While building our table, we had trouble finding a singular large piece of plywood. Every piece was either very small or already had more than one hole in it. Eventually, we settled with 2 pieces of plywood that had similar thickness to act as the base of the table. After we had already finished with our system, we noticed that our pump pumped too much water into our grow bed, more than our bell siphon could drain. In an attempt to fix this, a group member lifted the media guard and clogged the drain. We had to completely drain our system, remove the hydroton, and unclog our drain.
feel like there's a more effective method, but
No, this is the most effective thing we can do.
which took 2 days in class. We fixed our initial problem by using a smaller pump which allowed less water to flow into the grow bed.
In future versions of this project, we would improve our system by, first of all, using a singular piece of plywood for our base to increase the stability of our table. We would also add a larger grow bed to allow for more plant varieties and more overall produce. Finally, we would also have used a timer instead of a bell siphon, as to create an even more hands-off system. Using a timer would allow the user to let the system run without fear of the mechanical failures like clogging or overflooding as seen in a bell siphon system. Although we are very happy with our system, we feel like implementing these ideas would have made our system better for our user in the long run. Our advice for future students building a bell siphon system is, first of all, make sure that you properly clean your hydroton before you put water in your system. Don't make a mistake and dirty your entire system. Make sure you're using a clean hydroton. Next, before putting plants or fish in your system, make sure to test the bell siphon multiple times. You want to ensure that the water flow in your system is functioning properly before you place any fish in the tank. This will make adjusting any flaws easier. Also, when you're fixing the bell siphon, be careful with the media guard. Finally, monitor your water quality regularly. In conclusion, our bell siphon aquaponics system successfully demonstrated how fish, plants, and bacteria can work together in a sustainable ecosystem. We think that a bell siphon system is perfect for a third grade classroom. Thank you very much for watching.